All right, we are SHUTE Sensing Solutions, and we are the polymer optical fiber sensor company. My name is Kristian, as pointed out, and I'm responsible for sales and marketing here at SHUTE Sensing Solutions. I'm the first non-engineer to the company, and we are about 10 people here. So we like to call ourselves a mature startup. Initially, we are spin out from the Technical University of Denmark. And the first couple of years, we were in incubator there. And this week, we're just turning 10 years old. We are placed just north of Copenhagen here in Denmark. Our technology is a unique and patented platform technology. It's based on polymer optical fibers, and with this we can monitor strain, humidity, and temperature, hence the name, but now also vibrations. Our technology is based on polymer optical fibers, single mode and microstructured, as you can see up here. And with a cut through of the fiber, you can see the honeycomb structure with 36 holes running in the full length of the fiber, and the middle one left out. And this is where we can capture the light. Then we use fiber bright grading technology to make sensing points. So with the laser, we from the side make a small deformation in the core of the fiber to create FPG sensing points, and we can create multiple sensing points, and they can monitor different applications on the same fiber. For that purpose, we need an interrogator, and we manufacture our own interrogator. This one is made and optimized for monitoring humidity in concrete as it dries up and cures. And this is an 850 nanometer band or range interrogator, but I'll come back to the interesting part about that in a second. But the interrogator sends out the light through the fiber, and when it hits the FPG sensing points, it creates a different wavelength coming back to the interrogator, and we're able to monitor humidity, strain, temperature, and vibrations with that. It's a well-established technology, and it's been implemented in construction, medtech, defense, and energy industries. We do everything in-house, but we can make different custom-made polymer fibers, different shapes, structures, claddings, and so on. They are mainly for medtech companies, but we also make our sensors ourselves. And we have fiber sensors for the 850 nanometer range, and now also the 1550 nanometer range. Also, for customers that need a full solution, we can create that, including software and interface, together with, of course, the interrogator. But today, and the purpose of this introduction is presenting our humidity sensor made for the 1550 nanometer range. This would assist glass fiber companies and make them able to monitor humidity using their own C-band equipment, but have a supplement of polymer fibers for monitoring humidity. And the good thing about polymer fibers is, of course, that it absorbs water molecules, and it survives 100% RH. We've tested it in different environments. For instance, from the very wet concrete as it starts to more than 5 years in the very alkaline environment of concrete. But as Christina also mentioned, ours can, of course, also survive salt and non-corrosive environments, being of plastic. This is, of course, very interesting introduction for our part because we can assist colleagues in the field of structural health monitoring when they need to monitor bridges, mines, tunnels, or critical joints on pipelines. They can use their own or your own interrogators and your own sensors for strain and temperature, but you can use one of the ports for a humidity sensor. And the sensor that comes with a choice of housing, it can be stainless steel like this one, where you can use your own interrogator set and your own silica patch cable to bring it out to the length that you need it to monitor in. But also in a bit newer version we've also just made is a non or all non-metal housing here of PEAK, and we've got a silica patch cable, and with a small ferrule we connect the silica with the polymer fiber inside the housing here, which makes it very easy and accessible to use for structural health monitoring and other humidity sensing applications. Just my last slide here on the relationship between humidity and the nanometer change. As you can see, it's very linear, the relationship between the two, and we have also over here tested it or characterized it in a 20 degree environment. And we have, as you can see, it takes a bit of time to stabilize, but with simple signal processing, we're able to predict quite accurately where the relative humidity value is gonna end up. So in a couple of minutes, we're able to monitor humidity on change in humidity. We've also tested it to monitor in ranges between 0.2 relative humidity. This is quite new for us. Just got the results in a couple of weeks ago, and all the way up to, of course, putting it into to water, and it survives. And you just have to take it out and let it dry up a bit, and then it's back in business. And as mentioned, we've tested in different composites like concrete, but also MDO sidings, and also for monitoring humidity in oil. So if you think that this could be an interesting supplement to your C-band interrogator sensing system, then do drop me a mail or go in and contact me via our homepage, www.shute.dk. That was it. Thank you for listening in.